All right, so there is a tangent function graph. You might be wondering, do we have to know how to graph this by ourselves? Right? Because I made you do it for sine and cosine. What do you think? Do you think I'm going to make you graph this? Answer? Yes, from the memory. So I'm going to think out loud for you. This is what you should be doing when you want to graph a tangent graph. Okay, I'm thinking out loud. There's a unit circle. I'm going to use that to build this tangent. Oh, sorry. All right, well, all the corners. I can at least do that. I've done it so many times. I can go the other way. All right, that's good. Okay, so ready. Ooh, at 0, the slope. Mrs. Major says the slope. Ooh, slope is 0. So 0, 0. Where else do I have a slope of 0? Ah, pi. Pi is 0. Do you like how I'm thinking out loud? At 2 pi, and then a negative pi. All of those are going to be 0. Okay, what else did she teach us? She taught us that the slope of this line is vertical line. There's no slope, undefined. Ooh, so vertical asymptote at pi over 2. What about 3/2 pi? Yes, 3/2 pi. There you go. Okay, there's my basic features done. Is there any other thing that I can find the tangent value? I think I do. Which one? Pi over 4. That's the middle finger on my finger tricks, and the tangent value is the x and y are the same, so it's going to be 1. I don't need that necessary, but I can do it. Pi over 4. Tangent is 1. Okay, I know the basic shape. It's not a cubic. No, it's not, but resemble kind of. Okay, so that's done. That's done. So it's going to go like that. I'm done. Okay, so if I were you, I'll stop this video and try it by yourself. I didn't really memorize anything. I literally based everything off of the unit circle knowledge. Okay? All right, back. So now here we go. What are the features of it? First, let's find the period. That one wing is a period, right? Because the same thing repeats again. So what's the distance from here to here? What's the distance from -1/2 pi to 1/2 pi? That is pi. So I want you to notice that's different than sine and cosine. Sine and cosine had a parent function period of 2 pi. This one has a pi. Okay? What else? There will be no amplitude. Oh, vertical asymptote. All right. So where are your vertical asymptotes? I'm just going to list them. -3/2 pi. So all the negative, like, all the 1/2 pi's, right? Oops. Something like that. I just listed them. Well, here's the thing. We're like a little more smarter than that, so they like to come up with the formula for it. I'm going to give you the formula, and then I'll let you think about what it is. So vertical asymptote of the parent tangent function happens at where theta is pi over 2 plus pi k, where k is integers. You're like, what? Why is that a formula? Well, that means k can be any integer, -1, -2, 0, 1, 2, 3. You plug it in, it's going to give you the list of all the vertical asymptotes. So let's try that. When k is 0, it's just going to be pi over 2. Is pi over 2 on your list? Yeah. K is 1. Pi over 2 plus pi is 3/2 pi. Is that on the list? Yes. As k is 2, 2 pi plus pi over 2 is 5/3 pi. 5/2 pi. You can actually take k as a -1 too. So pi over 2 minus pi is -1/2 pi. So that's the formula that gives you a list of that. Okay, I need you to memorize it. I know, memorize it. Or build it if you can. All right, now we are going to transform it. I know you've been waiting for it. Same thing as the sinusoidal function. A is a vertical stretching. B is a horizontal dilation. C is the horizontal shifting. D is a vertical shifting. Right? Okay. Only thing I want you to remember is this right here, period. For sinusoidal sine and cosine function, I told you guys that the period is 2 pi over b. We use that so many times in our tests, our benchmark, right? 2 pi over b, 2 pi over b. What does it say over here? Pi over b. So you're probably thinking, why is that pi, not 2 pi? Because that pi comes from the period of the parent function. That's a parent function right here, without any shifting or any reflection, any dilation. What was the period of the tangent function? Pi. So instead of using 2 pi, you better use pi. Yeah? All right. Now let's get to the problem. Example 1, there's a graph. I notice there's no horizontal shifting, left and right. I gotta find A and B and D. Start with the D, midline. Midline saves alive, midline. I don't see anything up and down, so midline must be 0, D 0. Right, period. How do you find a period? Not 2 pi over B. Pi over B is a period equal to, let's find the period of this graph. I always start to do it from the vertical asymptote to vertical asymptote, which is negative pi over 4 to pi over 4. Sorry, you can't really read it well. What's the distance from negative pi over 4 to pi over 4? That is pi over 2. Oops, you can't read. Pi over 2. Miss Major, what? If that was too hard for you, you can also do it from the 0 to pi over 2. Okay, either way. So, period. Pi over B must be pi over 2. What's B? B must be 2. B must be 2. B is, by the way, the horizontal dilation factor. A is the vertical dilation. So for sinusoidal function, amplitude was pretty easy to find it, but this, it's not. So we are learning a lot of tricks over here. Okay, so bear with me. There's my parent. This is the parent one. Okay, parent one. Remember, tangent of pi over 4, the middle finger, y over x, is 1. Is 1. Okay. So here is how you want to notice that when there's a vertical asymptote, there's a 0. Right in the middle of it, better get 1. If it has a 2, y value of a 2, tangent value of a 2, that means a vertical dilation of factor of 2. 3, 4, 5, and vice versa, half, then vertical dilation of a half. What's the trick again? From 0 to vertical asymptote, find the half point, and then find the y value of that. So, back to our problem. Are you ready? There is a vertical asymptote. There is a 0. Find the halfway, which is over here. Doot, 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 doot. What's the y value? 1, which is same as the parent function. That means there's no vertical stretching up and down, so A must be 1. Oops, A must be 1. Okay, all right, next. We got to find the period for tangent. Pi over B. What is B? 2. That's it. I know, so easy. Next. There we go. Ooh, there we go. All right, so there's all the formula for the vertical asymptote. Let's review. The tangent of regular x has a vertical asymptote at where? Pi over 2 plus pi k. Remember, that's a formula I gave you for the parent function. Now we are looking for tangent of x over 3. So how you're going to set it up is just say that x over 3 is equal to that, same as the parent function, and you're looking for what x is. So how do I get the x by itself? You have to multiply 3, right? So multiply 3, then x is equal to, boop, 3 half the pi plus, boop, 3 pi k. Where's that? There you go. Okay. All right. Graph. First thing, what? Midline. Shift it 2 down so I can get rid of that. Only difference between A and C is the horizontal dilation factor. Then let's find the period of this graph. What's the distance from pi to 3 pi? 2 pi. So period is 2 pi. Well then, pi over b must be 2 pi. Cross multiply. 2b pi is pi. B must be pi over 2 pi, which is half. Oh, you couldn't even, oh, sorry, you couldn't even see what I'm writing. Sorry about that. There you go. All right.